The way we design, build, and operate buildings is undergoing a radical transformation. Welcome to ACE IoT Flight Logs. I'm Andrew Rodgers, co-founder of ACE IoT Solutions, and I've spent years immersed in the world of smart building technology. Join me as I learn from the industry's leading innovators, researchers, engineers, technicians, and more, how we can revolutionize the entire life cycle of the built environment. Get ready to take flight and explore the future of how buildings are delivered and operated. Hey folks, Andrew Rodgers here with ACE IoT Flight Logs. Today we're at beautiful Cedar Breaks Park on Georgetown Lake in Central Texas, and I have my good friend James Coleman from Princeton with me. James, can you introduce yourself?
My name is James Coleman. I'm a PhD candidate at Princeton University, where I also work in our facilities department as a building automation systems analyst. So most recently, before I started this PhD, I was a consulting engineer in New York City. And specifically, the kind of engineering that I did was around the design of modern open building automation systems, as well as data collection and management practices for large portfolios. So my sort of professional background is those two things. And then prior to that, I also had a background working in startups doing product development work.
Yeah, I think it's important because too often, I would say, it's not a rule, but certainly too often, we work with academics that maybe haven't had some real world experience to temper their either expectations or optimism or one of those things. I'm not sure. So today we're talking about 5 things broken about building automation and how we can fix them. It's a bit of a clickbaity title, but I think it'll be fun to go through this. And I think it's going to be fun specifically with you because you're one of the few people that I know of that's really working on this kind of both at like a tactical level. I know some of the efforts you're undertaking right now that are very like deep in the weeds on the technology side, and also at a more philosophical level. What does the industry need to do? How do we kind of put together the incentives that allow that to happen? So the number one thing I have here is interoperability. Like BACnet came out in the 80s. It promised interoperability. Why don't we have interoperability today? So kind of to kick that off, maybe what's your perspective? Like, why do we even need interoperability?
I think that, and obviously this is an excellent question and a great place to start, because it was a long fought battle just to get where we are today. And I think very often people think, well, we've been at this for quite a long time. We have BACnet. Surely we've arrived. We have interoperability. And we do on one hand and we don't on another. And so I think it's important to frame the conversation the way that you've asked, which is why do we need it in the first place? And I think that there's a laundry list of reasons why it's important to be interoperable. But I'd say the one that's maybe most important to me is flexibility. And so, or choice. And when I think about why it's so critical that the systems that we design are interoperable at the technical level, which is to say, like, machines are able to talk to other machines in a way that is standard and well understood. The critical part there is that if I have a system that I need to replace and manage over time, which is every building automation system, if the components of my system, my building automation system, are not interoperable using a standard protocol at the technical level, then if one of those two parts breaks, I am tied into replacing it by the product of a specific company or service provider. Whereas if I've done the legwork to make sure that my full hardware stack in my BAS is interoperable head to toe, when some piece breaks, and they always do, I have the full market of options to replace each piece, make sure I'm getting the best price, make sure I'm getting the exact features I want, and able down the road set myself up to have that system be serviced by the person who I want most to service that system. And so I think that first and foremost, technical interoperability, which is maybe we should distinguish between that term from semantic interoperability, but technical interoperability grants me choice and flexibility, in particular over the lifetime of my system.
So what you just described, as far as what BACnet does, I think when I look back at some of the historical documents and just even news, press releases around the release of BACnet, I think it was envisioned as this full stack interoperability. Can you explain a little bit about like how we got where we are today, where even in a building where I have multiple devices from multiple vendors talking to each other during the daily operation of the building, the owner still feels like maybe they don't have the choices they would like to have?
I, in my career, have often gone into buildings where people said, yeah, my building is open from tip to tail, and I am able to service any part with any vendor that I choose. And we get in there, and as you've alluded to, operationally, information is passed from terminal unit to controller, or controller to VAV, or to air handler, or whatever, machine to machine via BACnet. So I really can go stick my laptop onto the network and see devices and potentially change set points. But there's only so much I can do changing the externally exposed control points in my system. When we begin to think about the interoperable, like this, making the service side of this interoperable, what I think you're referring to is the fact that very, very often to modify the control sequences that live on a particular piece of equipment, I'm basically only allowed to do that if I have special authorization from the manufacturer of that hardware, whether that's because I've attended special trainings, or more often than not, as you alluded to, I have a literal license on my computer that allows me to fix an error in logic, or just like to improve a sequence. So just because I can pass messages around on a network in an interoperable way via BACnet, it doesn't mean that anybody can come in and actually service the logic that gets executed on my BAS.
Even if we get all this technical interoperability, like the ability for anyone to service anybody else's equipment and change programs as desired, it still feels like that's locking us into this model where I don't think we can get where we need to go as a planet with deploying advanced control technologies, because it's too slow. Like having a technician, it doesn't matter if it's on site or someone from the factory vendor, it doesn't matter who it is. The fact that we have to have a technician like go out and touch every VAV controller in order to instantiate advanced controls, it feels like there's something missing in the stack as we see it in current buildings to really solve that full interoperability challenge. Can you talk like what's coming? What do we need to be talking about there?
So I think there's at least two answers to the question that you just teed up. So there are two parts to the answer. So I think that the first part, which is how do we identify the opportunities for improving performance of existing systems that are already built, are largely interoperable? I think the answer to that question is via picking one of several semantic interoperability frameworks, whether that be Haystack, Brick, or the forthcoming 223P by ASHRAE. These are distinct from technical interoperability in that they aren't about can I pass an electronic message from one place to another, but they're about making sure that the meaning of what that message is understood on both sides of that transaction. And so to sort of tie it specifically into your question about how do I make sure that we're able to optimize the performance of buildings at scale, it, as you've said, is not feasible for the one guy who understands what the points mean in a given building to be responsible for tuning every building he's ever worked on, he or she. It has to be that we have a common vernacular, which we embed in our BASs, which allow any technician, whoever is most qualified, to come out there and tune the performance of a system, or to allow me to go and pick the absolute best software vendor who might say have the ideal analytics tool for my type of building. And it can't be that in order to get that person into my building, I have to spend a bunch of money up front to redefine what all the points in my system mean. It has to be that we have a common language where I can just pull in the best person for the job when I identify the problem or the need. So that's, I think, one half of that answer.
So do point naming specifications solve this?
No, I think that they are a step in the right direction. I think that having a point naming convention, which has been until recently, when we've had fairly mature competing semantic interoperability frameworks, Break, Haystack, S223P, that was the best you could do, probably. To say, as an organization, whether I'm a university campus or I'm a large corporate owner with hundreds of buildings, it was in your best interest to say, as an institution, we always name supply, air, discharge, temperature set points the same way. Like, that allowed me to procure more efficiently within my own portfolio. However, it doesn't mean that the vendor who has software that is the best at optimizing VAV boxes can necessarily come into my building very easily and deploy their solution. And so it's point naming convention at an institutional level is valuable, and people have, thoughtfully invested lots of time and energy in producing these. But as an industry, we'll be far more efficient in delivering high performance buildings if we have a common vernacular for how we define our equipment that we all use. And point naming is one method of encoding information, but it's not a particularly flexible one, and it's also quite hard to enforce. So I think these other solutions, which are more about embedding additional metadata, just provide a less brittle solution.
Yeah, I mean, I think with point naming, one of the challenges that a few of the challenges I've seen in my experience have been that package equipment you don't get to pick. And so all of a sudden you're like going through this building where every point on every VAV controller is gorgeous and beautiful. And then you hit a chiller and you have no idea what these four letters mean next to each other. Then the other side of it is that no matter how well thought out the point naming convention is, it can never take into account all of the different hierarchies. So I've yet to find a point naming convention that can actually model energy flow in that encoding in any meaningful way. Because sure, you can get like VAV fed by this AHU, but there's always exceptions to those rules in like one or two buildings where like the energy flows this other way. And because you've kind of have to pick one hierarchy, most naming convention rules that I've seen are not dynamic. There's not like a way to encode additional fields inside that naming convention. There's a fixed set of fields and you fill them in. And that tends to be where they fall apart. So it's one of those 80-20 solutions. Like you can do a lot. You can do 80% with point naming, I feel like, but there's 20% that you just never can solve. And that 80%, like you said, it's hard to enforce. Every time you bring a new vendor in, you have to retrain them. Like there's all kinds of challenges there. So moving to one of these interoperable, industry standardized semantic models is definitely a big improvement.
Yeah. I also think it's probably worth calling out that there's a requirement if you don't have an industry-wide semantic interoperability vernacular that we all agree to use. And I've seen this in the field in real buildings, that the only way to enforce that your organization's specific naming convention or even tagging convention is applied correctly is for you as an organization or for your vendor to build out a bunch of custom validation tools. And it can't be that everybody in the industry has to develop all of their own validation tools or it doesn't get done correctly. And so I think this is the thing. We're not big enough. I think we don't have the scale where we can choose to work in little silos. We have to build those tools together so we can all reap the benefit.
Yeah, and I know that Brick and Haystack teams, and certainly the 223P teams, are all kind of standardizing on at least one framework for validation.
Yes.
So there was a time when there was going to be like maybe a different validation engine for each one of those technologies. There will be like different repositories of validation rules for each of those different ontologies, but the underlying engine is all Shackle, which is going to make it much easier for application developers to tie all those things together to be able to ingest from any one of those ontologies, which I'm excited about. And certainly NREL, Gabe Fierro has been leading work there with building a motif that has some standardized validation that organizations, they may still want to customize it a little bit, but they can adopt it and start using it and at least get to some base level of interoperability for, the general use cases, and then potentially build out additional rules that support whatever, if you're a chip manufacturer, you probably have some weird equipment that's not in, everybody's office building, or if you're a, lab environment, university, et cetera. But getting this stuff out where folks can start building on top of it is really exciting.
Agreed.
This validation engine question kind of brings up, or topic brings up another thing that I'm a little honestly surprised about. A lot of our customers are commissioning engineering firms, so we work with a lot of them. And commissioning engineers, this is what they do every day. They go into buildings, they validate that the systems in the building are working as they should. Hilariously, they also, or ironically, they also need the data, and they need interpretable data to validate some of the building systems operations. But I have yet to find a commissioning engineer who has in their scope commissioning the point naming or commissioning the ontological definition of the points in the building. They all sort of hit it mid stride when they're trying to validate, VAV performance and realize the point naming is all wrong. And then it's like a huge, how do we solve this? And it's like, it feels like they're in a unique position because they, a lot of times, for top tier buildings, they're going out there and they're like doing 0 to 100% damper runs on every single VAV in the building. So isn't that the perfect time to validate that the point called, damper position is actually doing what it's supposed to do? I'm curious from your perspective, have you seen any commissioning firms like getting involved at that level? Or do you think owners have an appetite for, say, shifting some scope to them to help make sure they land on their feet when the building comes online?
Yes, in my personal experience, there was an assumption that often the commissioning agents were doing the validation. And in my old role as a specifying engineer, working alongside commissioning agents when buildings were getting ready to turn over, I had personally been the one discovering that whether it was point naming or semantic metadata encoding, I'd been the person who was realizing that it wasn't done correctly. And so, is there an appetite? Yes. From certainly the owner wants their commissioning done correctly, and certainly the specifying engineer has a vested interest in seeing that the contract documents were actually executed to the letter. I think, at least in my personal experience, it comes back to the problem that commissioning agents or MSIs, whoever has the scope of commissioning the tagging or the naming is done correctly, these folks often don't have the automated validation tools that they need to really do that job correctly. And any human, no matter how attentive they are, we're just not well suited to validating hundreds or potentially thousands of points looking for grammatical errors. Like, it's just not what we're good at. And so I think this is why it's so important that organizations like the Department of Energy are sponsoring the development of validation tools that we can all use. Just, we have the best of intentions. We just are not machines. That's what we should let the machines do what they're good at. Leave the things that we're good at to us.
That you talk about being a specifying engineer. What do you think in achieving this like future level of interoperability where we have operational interoperability, service interoperability, and semantic interoperability, or application interoperability is what I like to think of. Like, semantic interoperability is very precise at what it means. But for most folks, they're like, well, why do I care? And it's really about the application interoperability. That's why you care. You want to be able to deploy applications to your building without having to, re-engineer the integration every time.
That's right.
What is the role of that specifying engineer or owner's rep in achieving this?
So I think that the specifying engineer or owner's rep has a big part to play in sending the market signals to first MSIs as the sort of first line of defense, and then eventually to the OEMs, the equipment manufacturers, that we want your equipment has to make the job of delivering technical, semantic, and service and application interoperability easy in the field. Like, it cannot all fall on the MSI, or, which often is the case, the facilities teams who realize after the keys have been handed over, there's all these errors and things have to now be fixed. So I think that the role of the specifying engineer is helping send market signals via bid lists that say, look, if you want to be in my building, you have to have equipment that is going to be compatible with the forthcoming control description language, which would provide that kind of service level interoperability layer that you've been describing. You have to have haystack or brick tags available and exposed on a network when I plug you into this BAS system. So I think, market signals is, via the bid list is the key way that a specifying engineer can help the whole industry move in the right direction.
One question that we hear a lot, certainly at NexusCon, there were some panels that I participated in. We tried to put this to bed, I hope. But do you need to pick a horse here? As an owner, do I need to say, I'm going to use Brick, or I'm going to use Team Haystack, or Team 223? Or are we at a point where, because these interoperability frameworks are robust enough now, we can do the interoperability between them fairly simply using, machine translation?
Yeah, you absolutely don't need to pick a horse. And I think when you look at how the federal government via the Department of Energy is doling out money to support this work, I think it's very clear that they have the ability to translate between these frameworks as a core requirement of how these things get developed. And so, no, you don't need to pick a horse. The technologies are actually already being developed to do that machine translation reliably and well. And I think in the next 12 to 18 months, we'll see that become kind of a non-issue, if I had to guess.
Yeah, I think there's a lot of worry that, like, this is like lawn versus back. I don't want to buy, lawn, and then, in 10, 20 years, like, oh, I can't do anything with it. I need to, or it's not that I can't do anything with it. This is going to hold me to some specific vendor's platform, and I want that choice and flexibility from the interoperability. And I just don't see that being the case here, because all of these are open. The challenge with lawn was always that there was like this, licensing for being able to deploy the technology itself, and that's just not part of any of these systems. So you really do have completely open definitions for all these, and because of the Department of Energy's investment, shout out to the Building Technologies Office and Emerging Technologies and the Modeling and Simulation Department there, because we have specifically not only implemented these translation technologies between the frameworks, but we're also open sourcing all of those that I'm aware of, then that means that, we'll always, like, there's no way to rip away the interoperability here. It's baked in from the get-go. There's no way to pull it away later. This isn't some, like, the rug's not going to get pulled out from underneath you. You just got to, it's not that the picking a horse thing. It's like, it's not that you have to pick a horse, but you just need to get a horse. You need to get on a horse, any horse. It's fine. It doesn't matter which one, like, jump on the closest one, but you do need to adopt early, because it's going to end up saving you a ton year 5, 10 in your building lifetime, when you're trying to improve control or adapt to changing dynamics of equipment as it ages, all those things where you need the advanced applications and advanced control, strategies to do that.
Absolutely. And I think, to your point about investing early, what I haven't seen enough attention called to is the fact that these semantic interoperability frameworks are, or rather create, a bit of a virtuous cycle where the more that you invest in tagging your system out or building a model, the cheaper the next solution becomes to deploy in your building. And then when you go and capture some additional set of information that you had missed in that previous round of modeling or tagging, now again, the next tool that you procure becomes less expensive, and the value accumulates in a really nice way.
Yeah, I this is another piece of advice that I've been, trying to get people to understand, is you don't have to go into, you don't need to think of this as, oh, this is a new technology I want to deploy in my buildings. This is going to be a big capital expense. This really, and this is where I think it comes back to that specifying engineer. It's when you're doing any work in your building, this should be built into your scope. And that allows that value to agglomerate over time. And you don't need an entire model of your whole building in order to get value from it. You just need what you need for the application you're worried about today. But when you go to do the next application, like you just said, it's going to be so much more cost effective if you've started with that skeleton.
Yes. Yeah, and I think just on that note, I have seen, as a specifying engineer, semantic tagging or metadata modeling get cut out when it was some kind of vague scope in and of itself. Like when the goal of the scope was to do tagging, it gets value engineered out. However, if you're precise about, we're going to build a sparse model that is specific to this kind of advanced fault detection and diagnostics that I want to have in my building, it cannot be cut out. And so I think that not only is sparse metadata modeling possible and fine, it's also it's a great strategy for making sure that it gets into the building in the first place, because you create a dependency on it being in place for your actual end use cases to be delivered.
Wow. So that was just the first topic of these 5 that we want to talk about. Great conversation. Lots of good information there. Let's jump into number 2.
Let's do it.
Number 4 will surprise you. This is something that I think a lot of small and medium facility owners kind of struggle with, or maybe don't even realize they struggle with. I think you even hinted to it earlier when you said, you've gone into places where people say, oh, my building's open from top to bottom. You can do blah, 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 blah. And then you actually hit an application and it's not as true as they thought it was. So number 2, KPIs. How does someone know if they have a good BMS or a good building automation system? I think that as an industry, we need to be sort of focused, or we need some focus on this. We sort of I feel like we let vendor marketing define what good BMSs are, like by a feature set, and they all name their features differently, even if they're doing kind of the same thing. And so we end up with very apples to oranges comparisons. You're trying to, as an owner, it's very confusing, and you are relying on the specifying engineer, but even a specifying engineer is going to have a hard time keeping track of every vendor's, marketing nomenclature. So is there any standardization on reporting on this sort of control system performance happening?
No, not that I've seen personally. I would be curious to know if you've seen something that I haven't.
No.
Okay, fair enough.
That's the short answer. I hear it in people's, in subject matter experts, when I'm talking to them, I hear them sort of saying oh, well, the Siemens XYZ feature, that's very much like the Johnson Controls XYZ feature. And they do that. And it's why don't we have a matrix that's hey, optimum start, there's 4 or 5 different flavors of optimum start. Which one is implemented in this control system? Is it really dynamic? Is it, weather based? It feels like we could get to a matrix there that would help compare these things, because, and honestly, this gets back on the interoperability side, that primary driver, which I've talked about so many times. It's about choice. And so if an owner wants to use your BAS, don't you want it to be easy for him to take justification, or her take justification, and say, look, it checks off all of these boxes in the matrix that we said these are the features we want, and allow them to make that choice? I think so. But yeah, I haven't seen a lot here. I was curious what your thoughts were on it.
I will say, Andrew, that when I was a consulting engineer and I was specifically in the seat of we have 6 bidders and I have to go, and creating that matrix you described was half of my role on every single project, was just trying to figure out which features were the most similar and literally put them in a spreadsheet and say, these guys have this, these people don't, this feature is similar, but I can't quite call it the same thing. Yeah, there isn't a lot of standardization out there, and that it creates actually a lot of ambiguity and a lot of knots to untie.
Yeah. I do wonder, I guess the only effort I'm familiar with, and because I'm so far away from new construction, this is not my world at all, but I am aware of folks working to sort of define a shareable Division 2525 module. And I don't know, it definitely has a lot of stuff about the technology architecture for the operational technology systems in the building. I don't know if it goes so far as to standardize feature sets of an application like the control system. But maybe that's the industry, the part of the industry that should focus on that are the specifying engineers. Maybe it's bad for them because they're getting paid to build this spreadsheet on every project, but
right,
ultimately
true.
Somebody hates doing that, right? It can't be good work. Maybe that would be the one thing I would offer is that I'm aware of that's at least tangentially related, but it does feel like something we waste a lot of time on, is just trying to figure out how does this marketing term compare to this marketing term in real implementation.
Yeah, it's worth maybe mentioning or pointing out that there's many ways to write a specification, but one of which is the concept of a functional specification. And it's also worth highlighting or reminding listeners that the specification becomes a contract document that people are legally required to meet the spec. And so if I say, I mean, yeah, confirming that they have, we've already covered that's a separate problem entirely. But that is the idea, right? And so if to your point, we have a standard, either as an organization or as an industry, a set of functional specs that say you have to be able to implement trim and respond logic in compliance with guideline 36 for VAVs and their upstream air handlers. If I can define that in a functional way, it is on the bidder to make sure that they are in compliance, independent of what their market, like I don't care what their marketing term is, as long as it meets what I've said that it has to do. That might be one way to cut through the noise.
And maybe Guideline 36 is our foremost effort in that space on the control sequences side.
Yeah.
Yeah, that's a good point. So I guess that's one KPI. Does it implement Guideline 36 controls? You probably need your commissioning engineer to verify that for you. What are some other KPIs? Can we talk about, like, is comfort a KPI? Is it how many service calls you're getting? You're needing to service the system over the course of a year or whatever. Is utility billing? Like, a lot of these feel like there's a lot of nuance because of how many different building types, et cetera. What are some of these that can really be used to help someone understand if they have a good BMS?
Yeah, I think almost all of the ones you've identified are excellent in isolation. And then you realize that they often have this sort of double-edged sword component where they'll hurt a different component. So an example would be, for example, better comfort. Like, can I track that? It's tricky. Like, you can measure, obviously, am I getting more or less hot, cold calls after I implement some new set of sequences or some new fault detection diagnostic software? For sure, that's valid and quantifiable, which is excellent. But I think that there's a lot of precedent from certainly academic studies, but I've also plenty of anecdotal ones too, where people have achieved really solid occupant thermal comfort by doing things like closing outdoor air dampers for like many years at a time. And like, does that reduce hot cold calls because I'm not taking in any outside air, which is the thing that I have to temper, and that's the hard part? Absolutely. Are people going to enjoy the cold or flu outbreak with, like you may be suffering from right now that results from that? Like, no, probably not. So yeah, I think, which is all to say that I think that whether, like, should we be tracking how many service calls, how many hot cold complaints, what percentage of the time a particular zone is in its comfort band? That's even kind of a challenging thing to define, really. Are all those metrics good? Yes. But I think that when you are looking at, like, the key is to look at these things holistically. Like, it shouldn't be, did I lower my energy bills? Yes. But then now everybody's too hot in the summer and too cold in the winter. That's obviously not the goal. I think you have to sort of think about, how do I normalize thoughtfully by each of these dimensions, such that ultimately I want a building that has the fewest hot cold calls, the least equipment replacements at the lowest kilowatt hours per year, right? That's obviously, you have to kind of consider thoughtfully the numerator and the denominator.
Yeah, and I wonder, like, for a lot of entities, like, how those holistic metrics are a lot harder to track, right? Like, those are HR metrics more than they are building metrics. And,
yes,
we would be remiss to talk about buildings in general without talking about 330, 300. But, like, that's what you're talking about. Is like, that 3 is not, that's not how you decide if you have a good BMS. If you're suffering, your 300 is suffering at the cost of that. So if the operational KPIs are a little tough, worth tracking, but it's more of like, you shouldn't focus on one of them because it's going to, the rest of them will suffer. That includes equipment replacements, right? Like, you could drive your equipment really, hard in a way that was maybe a little bit more efficient, but ends up, replacing equipment every 10 years is pretty expensive. So what about some of these more that are around management side, I guess, or the fiscal side, like, the ownership, the ability to control who's working on it, those sorts of things that tie into the interoperability, really. How much does it cost to expand, et cetera? Buildings change. We know this, like, the use cases for buildings change over time. What does it cost me to adapt to those changes? Are those good KPIs?
Absolutely. And personally, those are the ones that feel most unambiguous to me. So, like, as we've said, do I want to track all those like hard quantitative metrics, I do want to track them. But how I interpret them it's not obvious how I sort of balance the trade-offs. However, there are some really straightforward to quantify metrics around what percent of my equipment is, as an example, actually does talk BACnet. I've been in plenty of buildings where people say, oh yeah, I'm open, it's all BACnet. But then I go to replace a dead thermostat and I realize that there's a proprietary protocol from the thermostat to the controller on the VAV. And I'm like, well, that's certainly not open. And now that I have to replace this, whether it's the VAV controller that goes down or the thermostat, I have to go back and buy this one specific brand. And that hurts me as somebody that hurts me as somebody who's responsible for maintaining a system. Like that's a kind of clear metric of, if I had been 100% open from the cooling tower on the roof to the thermostat on the wall, that makes sure that I know that when it comes time to replace things, I'm going to be able to get the best price because I can bid every single piece competitively. And so that's something which I think about a lot.
And I think, I think for a facility owner, that sounds good. But most of them that I talk to will sort of be like, yeah, whatever. Like, I don't mind. Like, I'm already going to be buying from XYZ vendor because that's my preferred vendor. But then if you just dig a little deeper and you go, well, what happens when they quit making that piece of equipment? And they all suddenly have trauma, right? Like, they've all been in this position where, like, they've got one building where, it still has this particular product line that vendor decided to stop making. And they're buying them on eBay whenever they show up because they're trying to maintain their own backstock, blah 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 blah. And I feel like that's the harder, like that's the choice. Like it's not just vendor choice. It's, can I swap this out? Period. And keep my building iteratively upgradable rather than like, oh, it's been 10 years, they've killed all those product lines, we have to replace the whole thing. And that feels like a place people get trapped.
Yes, absolutely. Yeah. And I think drawing one more comparison between some of these quantifiable metrics, kilowatt hours, to run my facility, there's more of a binary thing where if they sunset the actual software that is required to run my whole building, and I'm going to lose control unless I award this huge contract to the replacement software, like that's a binary, I lose control of my building. Not like the building doesn't operate optimally. I'm going to lose my asset for a couple of weeks of downtime or whatever. And that's really problematic, which is why, these metrics, maybe more qualitative metrics around what percentage of my system is truly open, easy to replace, able to bid competitively are the kinds of things I personally like to keep track of.
And then servicing that stuff. So that, your service contracts are something that you're going to be doing every year, probably for the lifetime of the building. And, if you have, like, this is the other interesting thing about that percentage open. Like, it doesn't matter if it's 99% open, if the like most important piece of equipment, you have to go back to that one vendor. You're always going to have a service contract with that vendor. That like puts that importance of getting, trying to get to 100%, or at least keeping it 100% of the critical equipment, pretty important to get competitive bid service contracts. Service. We just talked about service, as a good KPI, like how easy is it for me to select a service contractor? I feel like the ability to predict and manage cost with service is just so hard. So number 3 in our 5 things broken with BMSs and how we fix them, service. How much will it cost? So yeah, I know interoperability is related. Can you maybe talk a little bit about that?
Absolutely. I wish I had something more optimistic to say. It is very difficult to have any kind of clarity around how much something's going to cost if and when it breaks. I think that is unfortunately the kind of way of the world right now. To your point, or what you were alluding to, I think is that the more interoperable my system is, at the very least, I know that I'm going to be able to set up the way that I procure that, whether it's by a competitive bid or just through negotiation. It's going to make sure that I am at least able to try to get the best price for myself. Whereas if I have a system that isn't interoperable, it's going to be whatever they tell me it's going to be. And as you've also alluded to, often service providers will be hesitant to tell you ahead of time how much it's going to cost to actually fix something. And so at the very least, if you can be sure that you can go and get multiple quotes on getting this thing serviced, like that's your best shot at having good cost control.
The other thing I think that kind of hurts us now is how we buy service. With our product, we're going into buildings to collect data for some specific use case, whether that's AFDD or retro commissioning. And almost inevitably, at least in 10 or 20% of buildings, as you alluded to earlier, the building's open, it's BACnet, and then there's like one or two pieces of equipment that were just never exposed to the BACnet network because there was an integration use case at the construction time.
Yeah.
And it's so frustrating to me that this seems like the only way we can get a quote from the incumbent controls vendor is for some block of a technician's time that may or may not solve the problem. There's no sort of like outcome-based pricing. Is that something that you think can be fixed in this part of the industry?
Yes, I do think that there's a way to address this. And before I explain how I think we do it, because it's like a bit it isn't the current market setup today, so I had to maybe cue that up a little bit. But I think in my personal experience, I have had the counter experience to the one you described, which is I can't get anyone to give me an outcome-based price, which is to say that they'll fix the thing for this amount of money. I have been able to get that procured before. The challenge is that because in that scenario, the service provider is so afraid of not making their typical profit margins, the prices that I get back are just inflated beyond all reason. And I understand where it comes from, right? They're basically adding to their price, which is proportional to their level of uncertainty around what it's going to take to fix the thing that is broken or deliver the thing that I'm asking for. And so I understand where that comes from. But I think what it is a symptom of is the fact that very often I cannot go to let's say as an example, I have a building which is serviced by a large multinational BAS vendor, and they have a branch office with an exclusive territory, which is where my building happens to be. Just because this branch office is uncertain about how to do something doesn't mean that the one territory over is as well. And so the ideal world that I hope that we can get to is one where part of this uncertainty is because I cannot just pull in the labor that knows how to fix my problem with certainty. So my local technicians have to pad proportional to uncertainty. And so I think that as an industry, we need to push back on this idea that only my local techs are allowed to surface my building. We have to be able to expand our net when the problem calls for it. Obviously, I'm not advocating that anybody should be barred from working on my building. It's just that if you don't know how, that's fine. Allow me to go and seek out somebody who does.
That might be the crux of the challenge there. I hadn't really thought about that. And we actually have had that exact same experience. Like, hey, we need to expose these points, and we literally got a quote back for $170,000. And we're like, what are you talking about? And they're like, oh, well, we're going to like buy and license a new Jace that has all of the points for the entire building in it. And we're like, what? They're like, well, that way we know we can solve it. I'm like, so like that level of uncertainty, like if you went to a mechanic for your car, like, and they gave you that, like if they were like, oh yeah, we think it needs an oil change, and you're like, okay, well, I'm gonna pay you to fix whatever the symptom is by that oil change. They're like, oh wait, you want us to pay to fix what about if you pay us for your whole car, and then
yes, exactly,
we'll fix yours and it'll be great. And you're like, but you're saying it might only take you 10 minutes to fix mine? Yeah, but just in case, like, so I think maybe that is the crux of the challenge is like, why does the BAS service industry have so much uncertainty in their scoping? And honestly, like, I am going to go on a little bit of a rabbit hole here. I think that this has to do with the lack of interoperability, and specifically on the service contract side. Like a local service vendor is almost always oriented to one vendor. And because of the way those vendors disseminate their product lines and the information about their product lines, they are sort of at a deficit of information. And I have had multiple times to go like all the way up the chain through the local provider, the regional, distributor, all the way to the OEM to get the answer. And like, it's not in any manuals. It's not in the service, the normal service tech training. So I think like having even interoperability at that layer where the service techs are learning more about different vendors, platforms, et cetera, that's better for the industry as well. In potentially contrast to what we just talked about, like when I think of things that have shifted drastically, it's consumer electronics, right? Like if we talk about consumer electronics, back in the day when I was doing a lot more in the industrial automation side, it blew my mind as we were transitioning where iPads were coming out. And an iPad was, I don't know, at the time, $400 to $600, whatever it was. And it was like a 10-inch screen. It had capacitive multi-touch, high performance processor, could do anything. And then I was wanting to buy an industrial touchscreen, and the industrial touchscreen was like poor experience in every aspect, like lower resolution, resistive touch, no multi-point tracking, all of that stuff. And it was 4 times the cost. But then when I look at the iPad, like the iPad surviving being in like a diaper bag, like these are the same environments actually. Left in a hot car in a diaper bag is like the same as like 90% of the industrial touchscreen applications. Like, why am I paying 4 times as much for this? I think that shift has actually started to happen in that industry, but I feel like it's the same thing with BASs. Like if I bought, a $600 VAV controller, well, that's like the low end iPhone. I can get $100 like insurance policy for that for 2 or 3 years. That if anything happens to it, it just gets replaced. And it doesn't feel like we're anywhere close to that with building controls. And I don't know if it's like, obviously there's a big difference in scale, but it feels like there needs to be a transition of some of that technology from the consumer electronics or the availability of the technology into this space. Like, are there folks leading the way? I know you've been doing a lot of surveying of OEMs and vendors lately. Are there folks leading the way and kind of moving some of the more, on one side, I hate it because it's consumer based and like gets replaced easily. But on the other side, like it's kind of how we have to go to get the cost effective controls we need.
Trying to think of whether or not anybody stands out as having really been able to tap that economy of scale that the consumer electronics space does so well. I don't know that I can think of any specific vendor, but I will say that some product lines increasingly support, as an example, standard web hosting capabilities that allow somebody to literally, to use your example, go and buy an iPad and make that the HMI of whatever the thing is, a VFD or some custom room control setup. And so I do think that, like, is anybody really leveraging economies of scale from consumer electronics? Not that I can think of. I'm sure that there are examples, and maybe just not the ones that like I would be willing to put in my building, perhaps. But there are still some thoughtful things that even traditional vendors whose hardware may still be expensive, but they're making the ecosystem more open in a way that allows me to potentially use hardware that isn't necessarily from them to lower the cost of my system, which is nice.
Yeah, the other challenging thing, like again, going back to that industrial use case with like the touchscreen versus the iPad, is like you do that touchscreen, you have like one environment you can build your screens in.
Yes.
It's clunky. It's vendor specific. You can't use another vendor's HMI, authoring tool. Whereas the iPad, I can load apps from like whoever builds an app for it. And I feel like that's another thing that is like we need is more like sort of app store thinking in these buildings, which requires the application, the semantic interoperability. It requires the technical interoperability. And I think there may be some vendors kind of getting close to that too, with maybe hosting containers, that sort of thing on their controllers.
Yes, I don't want to give specific shout outs. I can't remember who has actually gone to public availability with their containerization. But yeah, you're absolutely right. There are a number of vendors. I can think of at least 3 off the top of my head who definitely the next 12 months will go to public availability with things like containerized software, which, to your point, so also having a bit of a product background, like whenever I see these absolutely god awful interfaces that were not necessarily the fault of the technician who had to construct it, it's more a product of the fact that they were constrained by the limited feature set of the graphic building tool that is tied to that one specific product line. Like the idea that in the very near, like, inside of a year, I could hire just like a normal front-end web developer to build the graphical interface for some component of my BAS and just host it on a container on my controller and have it all be local and robust and survive network downtime, et cetera. Like that is very compelling to me and something that I'm quite excited about. I think a step in the right direction, like a big step in the right direction.
That's awesome. So you're negotiating these service contracts. We know they're required. A lot of times it's building in, say, licensing cost for the software upgrades, et cetera. What are you getting? What is the value prop to the building owner other than just, continuing operation of their building?
Excellent question. And I'm going to do my absolute best not to be particularly negative about it because it's something which, unfortunately, I do have a fairly negative viewpoint on. I think at the end of the day, what is the main thing that you get from, like, to be clear, there are different kinds of service contracts that are out there, right? They don't all include the same scope of coverage of service per se. And usually the price is kind of proportional to what you get. As an example, like there are service contracts you can buy where if hardware breaks, they'll replace it, it's included. If reprogramming is necessary, they'll do it. Are those contracts exorbitantly expensive? Generally speaking, yes. But for for a limited set of owners who like really don't want to deal with it and like the facility must be operating at tip-top shape all times, maybe that's a price that they're willing to pay. I find more often than not what people are getting in their service contract, as you've alluded to, is the basic set of, we're going to make sure that your software is up to date. When there's a security patch, we'll make sure that that's deployed. But it's sort of almost like a base layer of IT support. And then the sort of willingness is the wrong word, but sort of the contractual obligation that if something is suspected to be wrong, somebody who is in theory knowledgeable about the system will come and diagnose it for you. And then it is up to you, much like your experience at the mechanic shop, to go forward with that or not. And so in some sense, really what you're paying for is somebody who can diagnose a problem most often. And then it's a secondary fee in order to actually fix the thing. And so in my experience, it's typically what you are getting, which is to say not a tremendous amount.
When you get that, okay, we diagnosed it, this is what's wrong, do you have a choice? Like, are you still stuck? Like, we're just gonna have to pay whatever it is they said? To some owners, are they able to self-service? Like, what are the options there?
Yeah. So to give a brief shout out to Princeton where I work, we are the exception to the rule. Like we have folks, like we have service contracts and people will diagnose that things are broken for us as part of their service contract. And then very often our guys in-house are so talented that they could just fix it themselves. They don't necessarily, if they're bandwidth constrained, maybe they'll authorize the work order. But oftentimes we are in this unique position where we're able to actually deploy the labor from in-house to go and fix the thing because our guys are just really, really good at their jobs. I think more often than not, unfortunately, you are kind of hamstrung and you're going to have to just, if you want your building to keep working or if you want that issue resolved, you're just going to have to pay whatever it is that they tell you. And we've said this already, and I don't want to beat a dead horse too much, but if your system is interoperable, like the sort of ideal state, and this is something which I was trying to, when I was a consulting engineer, was trying to get my client systems to this position where I could come and have the diagnostic be performed by more than one person, right? Like if I have the correct technical and service interoperability, then there's a scenario where I'm not able, like I can get kind of like a second and third opinion, which is the ideal case, right? And then I could sort of bid the replacement cost. But more often than not, unfortunately, they'll diagnose it as part of the contract, then you just got to pay them whatever it is to fix it, unfortunately.